Hi, in this video I'm going to show how to interact between MATLAB and OpenCV. OpenCV is an open source API for computer vision, and I'm going to show two ways to interact through it. One of them is directly through C++ by creating a MATLAB MEX-file, and another one is using the MATLAB OpenCV wrapper functions. The easiest way is to use the wrapper functions because you stay in MATLAB and you don't have to write any C++ file. But the C++ file might be more efficient if you can find a better, more efficient way of doing it, and also can let you access maybe functionality that is not supported by the wrappers. Yeah, so I'm going to show both of those examples, and the example that I'm going to show is the one I just showed here, which is background subtraction. I'm going to show two variants of this background subtraction. I think it's MOG2 and the other one is KNN. And yeah, the examples that I'm gonna do are listed in here. There are, as always, there are gonna be links for these two articles in the description of this video. This is for building MEX-Files, accessing the C++ functionality of OpenCV. You just have to execute this line, change to the folder where it is, building the MEX-file, and then just running a test harness that they provide. And the second example, it is this. You have to hit Open Live Script, and it's gonna just basically contact the MATLAB wrapper functions directly. Okay, so let's do the first one. To make the MEX file to interact directly to the C++ API of OpenCV, you have to do something like this C++ example that is provided in this example. You have the entry point function, which is called MEX function, and you have the left hand side and right hand side arguments. If you're not familiar with this notation, I understand that it's like a compiler notation. I don't have it here. Let's say you have something like this. So these input arguments are in the right hand side expression of the assignment. So that's why they call right hand side, and these are in the left hand side of the assignment statement. So they are called left hand side. So in this case, you have two right hand side arguments. So in this array, you're gonna have two elements. They are 0 indexed. So this is number 0 and this is number 1, and this is gonna be 2 because you have 2. And in this case, we also have 2. So two left hand side output arguments. So this is 2, and you have gonna have A and B in the element 0 and 1 in here as well. So yeah, so basically left hand side is the outputs, right hand side is the inputs. And then this in particular is gonna take the first right hand side argument is gonna be to determine the type of function that you're gonna call. So in here is gonna take the first argument, it's gonna verify through this MEX is char, not these functions that start with MX. This is an API that MATLAB provides to interact with the MEX arrays, and they only include it is OpenCV MEX, which is the header for OpenCV MEX things. But I understand that they should include the general MEX API because this is not particular for OpenCV but for MEX arrays in general. So in this, I'm checking, okay, are you an array? If you're an array, then I'm gonna convert you to a string, and then convert it to a string, verify that it's not null, and then compare it against the three options. Otherwise, I think it doesn't error out. This just leaves silently. This is just an example. This is not a production code. Okay, so for construct, you're gonna call the constructor, and for computing, you're gonna you're gonna compute the actual mask. So you're gonna take an input image and you're gonna return an image. The input image is gonna come in the right hand side, and the output image is gonna be on the left hand side. And finally, the exit function that really does nothing, but it's just to show that you can deallocate memory in there. Another thing to note in this file is that the background subtractor is not created dynamically. It's gonna be created only once statically. And we're gonna have a handle here, and it's the type of a background subtractor MOG2. Okay, so let's compile this file to have the MEX. So it's gonna be like this. It's not a regular MEX command, it's MEX OpenCV and the name of the C++ file. Okay, so I just compile it. Whoops, I already had it there, so I'm gonna delete it and do it again. Okay, so this is gonna generate the MEX file in here. Okay, now that we have it, we can, let's say, yeah, let's say that we can invoke it like this. Let's say compute and input image. Yeah, we can do something like this. You can call it just like another MEX file. Okay, but for that, the example provided a class that is gonna provide a constructor in here. So when you construct this class is gonna call the construct option with the parameters for the background subtractor. It's gonna have a get foreground mask, which is gonna call the compute, and it's gonna have a reset, which is just gonna call the destroy method and then call the constructor back again, and finally the release. That's so when you destroy this class, it's gonna call the destroy method alone. Okay, so let's go to the test harness that the example provides, and let's just run it. And first we're gonna create a video reader from where we get the images. In this case, it's gonna be cars going through a street. And let's create the background subtractor, which is the class that we have in here, and that is gonna call it's gonna create the wrap, the history, threshold, and shadow detection in parameters in a structure. We're gonna provide a structure with 3 fields. So this is gonna go to the C++ file. If I'm calling the MEX goes to here. It's the first part argument is gonna be construct, so it's gonna call the construct object, and the construct object is gonna take the right hand side and it's gonna check. Okay, your second argument. Remember, the arguments are zero index. So this is 0 and this is 1. So the params is in number 1. So check if the using again the MATLAB MEX API. Check if it is a structure. If it is a structure, then I'm gonna call this function, internal function actually, in which I provide the 3 scalars where I want to get the information to, and they're just 3 scalars: integer, float, and bool. And I pass the second argument, right hand side argument, which is a structure and is of a MEX array type. So I again use the MATLAB MEX API to get the field from the parameters, and I get the history, threshold, and shadow detection field, the 3 fields of the structure. Note that in MEX arrays, when you're traversing through an array or a structure, which are hierarchical types, it's like doing recursive traversal in a graph where all the nodes are MEX arrays. So when you get the fields, then they themselves are MEX arrays. The parent is a MEX array, and the fields are MEX arrays as well. So check first if they are not null, and then use another MATLAB MEX API to get the scalar from that array, from that next array. And then we need to cast it to a corresponding scalar type. So we cast it to integer, float, and bool. So now we have our 3 values. And then remember that the background subtractor we created is statically, so we have a handler for it, and in that handler we just call the setter methods to pass the 3 parameters, and that's how we construct the object. Of course, maybe in a production scenario, instead of referencing a static allocated background object, maybe you create the object dynamically here, and in the destroy you release the memory or something like that for memory efficiency. Okay, so now let's go back here. We already constructed the object, so let's go back to the test harness, and the test harness is going to use a blob analysis. The background subtractor is going to take away everything that is not moving. So what's going to remain is going to be the cars and the shadows, because the shadows are moving as well. So and then for the blob analysis, it's easy to find the cars because it's the only thing that is moving. So we're gonna only get the bounding box. So we set that we don't want centroid, area, nothing. The minimum block area is 1000 because the car should not be smaller than that, and we just want the bounding box. Okay, so we want a video player as well to display the image along with the bounding box of the car. Okay, so let's read the images, and I'm gonna put a breakpoint here. I'm gonna hit F5 a bunch of times because I want to get an interest image. The one problem with these examples is that the initial images of the video are not interesting, so you have to run it a little bit to get the good ones. We have not obtained the interesting one yet, but we hit the frame count number 10, and in this we apply the reset method that is just applied just to show it. And again, this is gonna call the destroy method, which is gonna go in here and do nothing, and then it will construct the object again, which calls the same functionality that we call in the constructor. Okay, so there was nothing really special in there. So let's remove the breakpoint and let's keep hitting F5 until we get an interesting image. Okay, we finally got the car. So now let's go to this method from the class, from the handle. And again, they have this tendency of putting this as a function. It's really a method. And you can see here that is a method of the class. Yeah, if you haven't seen my previous videos, you have seen that I like to call things like this because it's clear. Again, I hope sometime in the future MATLAB examples stop doing this, because when you see this, my first thought is this a local method? Is this a global method? Where this function is coming from? What it's doing? But if I see it like this, okay, I have it clear. This is from the background detector. It's doing something, so it's easier to recognize what it's doing when you put it into a method form like this. But anyway, okay, I'll stop ranting about that in my future videos. Okay, so now we are in the get foreground mask, and this one is gonna call the compute method inside the MEX-Files, and it's gonna go here, compute a foreground mask, and this is gonna this is important here because when you interact with OpenCV, you have to do some type marshalling, and that is converting the types of the matrix type of MATLAB to the matrix type of OpenCV. OpenCV has this mat type, and so MATLAB provides in this case this should really come from this API, from this header. It basically converts from the MEX array to the mat type of OpenCV, and then the image is passed to the background subtractor using the apply method, which is the object that we have statically allocated in here, and then it gets the output in this local mat type of OpenCV. And again, we cannot do anything with it. So we have to use another function from the OpenCV MATLAB API to convert that OpenCV mat type into a MEX array. And the MEX array is placed in the first element of the left-hand side, that is the outputs. And this left-hand side is again the same one that you return down here. And this one eventually is the same one that you get in here. So the image is passed to the background subtractor inside of MOG type, and the mask is returned. So notice that the size is the same, 360 by 640, same size as the input, and the type is unsigned. And again, this is a mask. So it is black and white. It's grayscale. So you have the color dimension, so that's why you don't have the third dimension. And this is how it looks. It basically eliminated everything except the cars and the shadows because they are moving. And okay, so it is gonna check if it is 0, and the reason for this is because let's check the unique values of this. So it's 0 or 127. So but by doing this, now you have 1 or zeros. but I have to check on this. Yeah, so you have 0, 1 now. Okay, so with that mask, let's go back to the harness. We get the mask in here, and we pass the mask to the blob detector, which expects a Boolean image here, and that easily detects the bounding box because the car is the only thing that is moving. And then finally, we're gonna introduce that bounding box into the original image to get the output image, and that'll give us the bounding box in the car. So we are able to detect the car by just subtracting the background, given that the cars are the only things that are moving. Okay, so let's take away the breakpoint and let's just get the video player to see the rest. And it's pretty fast. Okay, finally, when we finish, we release the object, and that calls the destructor, which is gonna call the destroy method, which is basically doing nothing, but in a real example, this will be releasing the memory. Okay, so that's it for the OpenCV example. For the C++. Now we're gonna use the MATLAB wrappers, which is easier to use. Okay, so for that, let's just run this example, and we're gonna get another video. In this time, instead of cars, we're gonna detect people, but the principle is the same. And we use the clib OpenCV, and this is gonna give us the background detector, and this is gonna give us the marshalling utilities to convert from a MATLAB matrix types to OpenCV matrix types, and vice versa. Okay, again, we have the three same parameters, history, threshold, and shadow, and this time we're going to use a KNN background subtractor instead of the MOG. And notice that we are calling a MATLAB function to interact with this. And this comes from this one. As I mentioned, this is the API that gets you the background subtractor. Okay, but it also provides a bunch of functions as well. You can by doing autocomplete, you can see all the things that the MATLAB OpenCV wrapper has. I have seen a Kalman filter, I have seen Harris corner detection, affine transformation, geometric transform, triangulation probably has SLAM stuff in it. A triangulation I saw as well, and yeah, there's a bunch of things in here. So in most of the cases, the wrapper is gonna solve for you, and you don't have to go to C++. But if there's no choice, you have the option of doing the MEX-File to interact through the C++ API. Okay, so now with this, we have a pointer to the background detector, but that doesn't work for us. So we use this Vision OpenCV util get this function from this namespace to convert the pointer to the actual background detector. So we have the background detector in here, and then we set for the background detector, we set the samples to 2. Okay, now we're gonna create an empty mask for all the frames in the video of the same size of the image, and we're gonna read the first frame. And again, I'm gonna the first one is not interesting. So I'm gonna keep running this until I get an interesting image. I'm gonna pause. Okay, I got an interesting image, this one down here, but let's take a look at the original one. So the original one has a background like this, and again, the background subtractor is going to remove everything that is not moving. So again, the frame is a MATLAB matrix type, so we have to use this util create mat to convert from MATLAB matrix to OpenCV matrix. Okay, and that is from this namespace, Vision OpenCV .util.create mat, and that gives us a couple of objects. These are the objects mat and d and x input array, and we use the second one to interact with the background subtractor. So notice that the first one, which is for the input, we pass the input image, but the one that is output, we don't pass anything. We just get a buffer. And that buffer is passed as the output, and the input is passed as the input. Again, for both of them, is the second argument that we use. And then we call the apply method from the background subtractor, and we get the output. But again, this output, let's execute this output we cannot use. We get an X output array, so we have to use, again, from the same namespace, vision opencv.util.getImage, we convert from OpenCV matrix to MATLAB matrix, and now we can display the image. Let's take a look, and this is the mask, the background mask. Yeah, so pretty easily it detects the person that is moving, and the shadow, which is moving as well. Okay, so this is between 0. Let's take a look at the unique values of this. Yeah, so you have a middle value, maximum value, and yeah, so we want to rescale it to be between 0 and 1. And now, but you have this middle value still, so we're gonna cast it to the base type. Right now it doesn't have a base type, but we want to have the same base type as the input image, which is an unsigned integer 8. So by doing this cast and using like with another matrix, it's gonna pick up the base type from this argument, and it's gonna apply the same base type to this array. So now we don't have base type, and after this we have a base type. And by casting to unsigned integer 8, we lost the middle values because you have integers now, you don't have floating points. So now we only have 0 and 1. So what that means? It means that the background is 0 and the moving object is 1. So if you multiply the mask in all the 3 colors of the original frame, you're gonna get rid of the background. And that's precisely what happens here. Okay, so let's take a look at the foreground. So we effectively got rid of the background. And yeah, that's about it. And now we just display that in the video player. So let's take away the breakpoint, and yeah, so in this video basically I show how to interact with OpenCV directly through a C++ API using a MEX-file and using the wrappers from MATLAB. And again, the easiest way is using the wrappers because you don't have to write anything in C++ and probably it's more efficient. But if there's no support for that, I guess you can go to C++ if you want to do something more flexible. Okay, so that's it for the video. Thank you very much for watching.